Okay, so for today's video, we're going to be doing another question about optimization, but this time a harder question. Okay, so the question is as such. So a farmer wishes to create a rectangular enclosure A, B, C, D. So they would give you a diagram that looks like this, of area 525 meters square, as shown below. Okay, so we can already just label that real quick, saying that the area here, so everything in the middle, is 525. Okay, then the fencing used for the side AB costs $11 per meter. So this side right here, AB, we're going to label it like this. So this one is $11 per meter. Okay, and then we have the fencing for the other three sides costs $3 per meter. So we can also put that in like this. So you can see AD, DC, and CB, all three actually have the same price per meter, so 3. I think it's really good for understanding purposes to label the diagrams as you go. Okay, then the farmer creates an enclosure so that the cost is a minimum. Find the minimum cost. Okay, so once again, this question, you can tell that it's going to be optimization, and the reason is because of this part right here, because you want the cost to be at the minimum. So if the question was also asking for the maximum cost, that would also be an optimization question. Okay, so I do recommend though that if you want to do this question on your own, at least try it, you can pause the video now. Okay, so let's see what we can do about this. So what we know is that the area here is 525, but what makes up an area when you're talking about like a rectangle or a square? So the equation for that is usually two sides which are perpendicular to each other. You pretty much times them to each other. And that would give you then the area in the middle. So for us, for example, let me get here. So for the area, we basically have like one of the sides timed one of the other one that's perpendicular. So just for this, I'm going to be using, so AD, here this one, times AB, like that. And this will give you the area. Wait, let me make it there, just so it follows the code. Okay, so that's what we know so far. But now what we want to do is we want to pretty much make like an equation for for the price of each of the sides, because you can see each side has a different price. So you want to make an equation for it, because you remember the rules that the steps that we used every time for optimization. We need to find an equation which represents what we're looking for. And in this case, because they're talking about the enclosure and the price, because we're not given any distances for each of the sides, you pretty much want to have an equation that talks about the cost. And we're going to call it the cost function. So how do we do that? Because so far we only have this equation right here, but it's not really helping us much, right? So what we're going to do is, as you know, a function usually has a variable which you call x, right? So what we're going to do is we're pretty much going to use these sides, but we're going to rename them in such a way that they're called in terms of x. So let's call this special one AB. Let's call it x. Okay? So now that we have x for this side, how would you call all the other sides? So to be able to find that, we can use this equation that we found already. Because look at this. So first of all, what's the area? So that one we already have, it's 525. So you can just plug that in. Oops, there. Okay, and now AB, so this one we called it X now, right? So you can just replace that with X. There, X. And do you see how actually now the only thing that we don't have is AD? So we can solve for this AD, and that would give you an expression in terms of X. So let's do that. It would look around like this. So if you want to move the X onto the other side, you divide it. So divided by X, and that's equal to AD. Good. So now we have AB, that one is equal to X. Now we can label all the other sides. So AD, for instance, we know already is going to be 525 divided by X. What about CB? Would this one be any different? No, right? Because this one, if you follow exactly the rules of a rectangle, so the opposite sides are always the same length. So you would find CB to also be 525 divided by X. Okay, here comes the tricky one though. What about DC? How would you call it? So this one's a little bit tricky just because even though the price is the same for these three, but now X, what it is really, it's more a length. And so therefore it would actually have the exact same one as AB, which is opposite to it. So you might not think so, but this one is actually also X. So you got two sides X, and then 525 divided by X on the two other sides. Okay, so how does that help? Well, let's try and see what the overall cost would be of our entire, of each of the sides together. So let me bring an equation. Okay, so we're going to call it C, and this is because it's a cost function. You could call it anything. You can call it f of x if you want. But so here I'm going to call it C. So the equation for all the costs, we're going to call it as such. So we have the first side, we have AB. So AB, I'm putting it like this, but you can see that AB is a length, right? So the length AB times here times 11, because for each meter in AB, so let's say imagine AB is 7 meters, then you would get 7 times 11, and that would be the cost of that fence AB. So whatever the length of AB is, it's times 11. Then for the next side, we have AD. So we have AD, and this one is timed by 3. The next one, DC, we have DC times 3 again. And then for the last one, CB, so CB, this one is timed by 3. Okay, so this is how you could interpret basically the function of the cost that's going to be total. Okay, so these, however, it pretty much uses the old way, right? Because this is how, if you don't know how to name each of the sides, you would just call them AB or DC. But what do? We already replaced these by something in terms of X. So we can just do that. So let me, Okay, so this is the exact same one. It's just I wanted to do it with you, but I also want you to see it a bit more clear. I just color coded it because you can see AB. This one is a different color as the other ones, just so you can see what we're doing. Okay, and so what we're going to do here is we're going to replace each of these length, so like AB, AD, DC, and CB, by their new name that we already made up. So AB, this one we had as X. AD we had as 525 divided by X. DC is X, and then CB is the same as the other one. Okay, so this one also looks like a lot, but no worries, it's getting there. Okay, so what would you do next? So we can actually simplify each of these terms and make it a little bit clearer. So let's see. So this one, there's not much to change, right? We just got x times 11. You can also call it 11x. And then here you can also already do the multiplication. So what would it be? If you do 525 times 3. You can do that on your calculator. And you would pretty much get this. So 1,575. Okay, and then for the next one, so x times 3, you can simplify to just, there, 3x. And then this one here is the same as the previous one we did. So we get 1,575. I'm just putting a comma just so that it's easy to read the number, but it's not necessary if you don't want to have it. Okay, so we got that. Now what can we do to further simplify? So you can see there's some common terms. So for example, here you can see the 11x and 3x, these you can add together. So what would that be? So 11 plus 3, we get 14. So it would look like this. And then these two right here, because they have the same denominator, so you can just add the tops. And if you do that, you would get the value here. So it would give you 3,150 divided by x. Okay, let me put that on in black. Oops, there. Okay, so this actually gives you then a function. So in this function here, you can see you have the overall cost of each of the, of all the fences together. That is a function. So what does it really mean? So pretty much x will be the distance of AB, and you might, so pretty much like whatever length you have, you can plug it in this equation and you'd see how much it costs. That's all that it means pretty much. Okay, before we move on though, I do want to point out that there is another method to find this, and it might have been for some people, wait, I don't know where to put it. It might be your way of doing it, so I just want to show it just in case so you know it's the same thing. So I'll just call this method 1. And so there's actually a second method you could do. I'm just going to bring it in for you, just so you can see it. So here, do you remember at first, see we did AB times 11, AD times 3, so we pretty much did them one by one. And this second method, it's not really another method, it's just a different way of calculating, which would actually bring you to the same result. But you can see here, you isolate the 11 and times it by AB. And it might not seem important, but then you see it here. So you can see 3 times, and then within the brackets you have AD, DC, CB. And this is just another way to do the exact same thing, but it's also clearer if it can be clearer for you. And I'm just going to bring in the steps for you if you want to follow that one. So you can see it would look like this after we change the values of each side and we plug them in. If you keep solving the inside of the bracket, you would get this right here. And then if you do the multiplication, you would get, so this fraction, 11x, 3x, and then if you simplify this further, you'd get this final answer that we got before. So overall, either one you pick, you can find the exact same value. Okay, so what we're going to do now is I'm going to keep this equation. I'm going to get rid of everything we did because we don't need it anymore, just to save a little bit of space. So this is now our final equation. Okay, but what does it really do? Because now what we want is, okay, we have an equation for the cost, but we want it to show us what the minimal cost would be. And this is where calculus can come in. But for this one, I'm telling you already, if you are doing AI, you cannot do this one with calculus. But I'll show you how to do it. So pretty much what happens is, so you got this equation, and if you graph it, I'm going to show you how it looks. So this is how it looks like if you graph it. And so therefore, if you want to find what the minimal cost is, you'd look for a minimum. And so on this curve right here, you can see there's a minimum right there. But before we look further into it, I just want to point out a few things about this graph right here. So you might not have seen one like this, but you can see it splits. So there's one part here and another part right there. How would you know which one to pick? Because what if the question was like ensure that the cost is maximum or something like that? Would you pick this maximum? You might feel like you should because it is a maximum point, but this is not actually the one you'd pick. This is because you can notice this whole part of the graph on the x-axis right here, this entire part is actually negative. So if you understand really what the x means in your equation, so it pretty much means, right, that x is a distance and it will give you a certain cost. But how could a distance be, for example, negative 50? It's impossible, right? So you can't have like negative distances. It's not possible. And so this is why you pretty much ignore completely this whole part of the graph and you only consider this one right here. Okay, so I just want to point that out. Okay, and now how would you know which one you would pick? So now we can do, okay. So do you remember I told you that you can't use calculus if you're an AI here? Let me show you why. So, you know, in AI, you pretty much learn about a few types of derivatives that you can take. Let me show you how this one looks. So this right here is the derivative of our original equation c. So this is c prime. And this is a type of derivative that, like, when it's fractions like these with the x at the bottom, this is one that you do not learn on AI. But if you're not an AI, obviously you can always like use this method if you know how to do it. And so how would you do this? Pretty much. So to find exactly what the minimum is from here, you would do this. So you would have the derivative and you would equal it to 0. Why 0? This is because, look, right here at the minimum, the derivative here would be flat, so the slope of the derivative would be 0. And so that's how you would be able to find the correct x value or value of this side, which would give you the minimum like price. So let me show you how to do it then if you don't use calculus. It's very easy. You pretty much just go into your calculator. So you get your calculator and then you use the option to find a minimum point. You'd find it right here. And it should look like, this one looks like this. So the point is this, 15,420. So why? This is because basically the 15, this is the x value. So it tells you that the minimum is at 15 right here. And 420 is the y right here. Or actually you can call it the cost. So how do we interpret then this result? So what happens is pretty much it's saying that the minimum is at when 15 is the value of x. So that your x here is 15. And then what happens is here, the 420, this would be your final answer. So what it means is at 15, when x is equal to 15, it means that the overall price of all of these fences, they're actually equal to $420. Oops. That was a mistake. Let me bring it here. Sorry. Okay, so here, like that, you have C, so the cost is equal to 420, and this is the minimum price that you can get with this. You can try it out. You can see. So, for example, look here. You have x equals 15. So, what would be the total cost of this fence right here? So, 15 times 11. Let's take the calculator out. You get 165 for this one. For on top here, oops. So you would get 15 times 3. So that gives you 45. That's for the top one. For this one up here, you would do this. So 525 divided by 15 times 3. That's 105. And then for the last one here, it would be the same thing, so 105. Okay, and then if you do all of them together, so 105 plus 105 plus 45 plus 165, and you get 420. That is your final price. You can also check this out. You can also find the area right here. But to do this, you would find here, so 525 divided by 15, that's 35, and then times 15. And if you check on your calculator, it would give you 525, and that would be the area. So that's how you find it. Now let me show you real quick the mark scheme. Oops. No. Okay, I hope you can see it. Pretty much here we have method 1. So if you look back at what we did, this is exactly what we did. And I just want to point out that here we have method 2, and this one is because, look, we considered side AB to be x, but what if you consider AD to be x? And this pretty much gives you the alternative option of like solving it like that, but the price is the exact same, so the final answer is the same. But this is just so that you're aware that sometimes a lot of methods can work, and you can also check out this. So you can see here they go either, and you can do a sketch of the function, finding the minimum point, finding it on the graph, and finding the answer. Or you can do, like I said, you can also find the derivative, equal it to 0, find it. So it's really just up to you, but you still get the exact same marks. So that's really great. So yeah, hopefully this was helpful, and I'll see you guys next time.